This is 3.6, Finding Zeros and Solving Systems. We're going to start this set of notes with finding zeros of a quadratic function. So finding a zero means figuring out where the y value is equal to 0. So for each of these, we're going to start by taking the y, or the f of x, or the g of x, whatever's there to represent y, and making it 0. So we're going to say 0 equals x squared plus 6x plus 8. And then, like we did in 3.3, we're going to solve this equation by factoring. So we're going to start by doing a factor pair list for 8. So 1 and 8, 2 and 4. And we're going to pick the pair that gets us a positive 6 when we add or subtract. So that's going to be positive 2 and positive 4. And we're going to set up our factors. We're going to say x plus 2 and x plus 4. And then to solve with this equal to 0, we're going to set each set of parentheses, so x plus 2 and the x plus 4 equal to 0. And then we're going to solve. So we're going to subtract 2 to get x equals negative 2. And we're going to subtract 4 to get x equals negative 4. And those are the zeros. Another word for zeros, or another phrase for zeros, are x-intercepts. So we can check our answer by graphing this function in Desmos and looking to see what the x-intercepts are. So I'm going to skip around a little bit. We're not going to do all of these problems, just like we're doing in class. I'm going to skip to the next row and do the one on the right. So the one on the right is a little bit different. The one on the right only has 2 terms. So at first we think, uh-oh, I'm not sure what to do with this. But remember, what's the first thing that you always check when you're doing a factoring problem? You always check for a GCF. So both of these terms have an x. So I can divide out an x and turn this into 0 equals x times x squared over x is going to reduce to just x, then plus, and then 11, and the x's for the 11x cancel. When we've encountered this before, where we just have an x by itself, we've turned it into x plus 0 as a factor. And then this looks like the problem that we just did. And we can say x plus 0 equals 0, and x plus 11 equals 0. Well, x plus 0 is just going to be x. Nothing changes. So we're going to end up with x equals 0. And then we can subtract the 11 and end up with x equals negative 11. The next example that we're going to do in this set of problems is the next row, the one on the left. So the one on the left, first thing I'm going to look for is a GCF. The instructions say find the zeros, so I know that I'm going to say 0 equals something, but I'm going to look for a GCF. I don't see one. No x's for all 3 terms, and no numbers that I can divide by all 3 terms. So I'm going to go ahead and move forward with slide and divide. So I'm going to slide the 4, and that's going to give me 0 equals x squared minus 19x minus 20. And then I'm going to do factor pairs for 20. So 1 and 20, 2 and 10, not 3, but 4 and 5 works. And I need the pair that's going to get me a negative 19. So if I do 20 minus 1, I get positive 19. How about I flip the signs? What if I do positive 1 minus 20? That gets me negative 19. So I'm going to go ahead and set up my parentheses with x plus 1 and x minus 20. Remember that we're in the middle of doing slide and divide, so we have to do the divide part. So I'm going to divide by the 4 that I slid in the first step. And with slide and divide, if it divides to an integer, then you go ahead and divide. If it doesn't, like 1/4, you take the bottom number and put it in front of the x. So that's going to make that 4x plus 1. And then 20 divided by 4, that does divide to an integer. And we get 5. So then we're going to take 4x plus 1 and set it equal to 0, and x minus 5 and set it equal to 0. For the 4x plus 1, I'm going to do 2 steps. So I'm going to subtract 1 and get 4x equals negative 1. And then I'm going to divide by 4 and get x equals negative 1/4 as one of my zeros. And then for x minus 5, I'm going to add 5 to both sides of the equation. And my other 0 is x equals 5. The next problem that I want to do is the one on the left here. G of x equals 3x squared minus 3x. This is very similar to the one that we did a couple of examples ago with the 11 in it, because I'm looking for a GCF. So 3x squared and 3x are both divisible by 3. They also both have an x in them. So my GCF is going to be 3x. So we'll say 0 equals 3x times 3x squared divided by 3x is just going to be x, and minus 3x over 3x is going to be minus 1. And again, we have an x that doesn't have parentheses around it, so we're going to turn it into 3x plus 0 along with the x minus 1. And we'll set each of those equal to 0. So 3x plus 0 equals 0, and x minus 1 equals 0. And then we're going to go ahead and solve this. So 3x plus 0 is just going to be 3x. Dividing by 3, we're going to get x equals 0, because 0 divided by 3 is still 0. And then we're going to add 1 and get x equals 1. So that's finding zeros. The next thing we're going to do is we're going to solve what are called systems of equations. A system of equation is more than one equation. So if you look at all these examples, these all have 2. There could be 2, there could be 3, there could be 4, there could be 20. We're just going to deal with 2. And to solve these systems, we're actually going to use Desmos. You may remember from Algebra 1 solving these using algebraic methods where you take one equation and plug it into the other equation. We're not going to do it that way, because as the exponents gets bigger, that gets to be more and more challenging. So to start off, the way we're going to phrase the first set of questions is we're going to say, is a point a solution to a system? Well, if a point is a solution to a system, it's where the lines intersect or where the curves intersect. So I'm going to hop over to Desmos. For this first example, we're looking at the point 3, negative 5. So I'll hop over to Desmos, and I'm going to go ahead and graph 3, negative 5. And we can see it down here towards the bottom of the screen. Then I'm going to go ahead and I'm going to type in the 2 equations that we have for our first example. So x squared plus y squared. And then we're going to say minus 7x plus 3y. So minus 7x plus 3y. And that equals 28. So there we go. We have our nice big circle. Now already I see a problem, because if the solution has to be the intersection point of the two curves or the two lines, then it has to be on both equations. And right now, the point that we have is not on the circle. So I'm betting the answer to this is no, but let's check. So then I'm going to type in negative 2x plus y. So negative 2x plus y equals 4. And sure enough, if I look at where the green and the blue intersect, I've got some gray dots that Desmos shows me, and those intersection points are right there. It is not 3, negative 5. So for this first one, I'm going to go ahead and I'm going to say no, not an intersection point. So let's do the same thing, but let's try it with the one on the right. So negative 1, negative 4 is our new point. So I'm going to go into Desmos and clear out what we had and put in negative 1, negative 4, and then type in our equations. So negative y squared plus x, and then minus 12y equals 33. And already we see the same problem that we had with the last one. Our dot is not on the first equation, so it's not looking good. But let's check. So then I'm going to do negative y squared plus x squared plus x minus 24y equals 81. And sure enough, that line, that equation looks like it gets pretty close to the point, but it's not on it. The intersection point is actually right there at 1, negative 4. So it's not negative 1, negative 4, it's 1, negative 4. Okay. So we're going to say again for this one, no, not an intersection point. All right, let's see if we have any better luck with the bottom two. So we've got negative 1, negative 3. So negative 1, negative 3 is going to be our point. So let me go in here and clear this out and do negative 1, negative 3. And we're going to go ahead and type this in. So negative x squared plus 2y squared. So negative x squared plus 2y squared. And then minus 2x plus 8y equals negative 5. All right, so we're looking pretty good so far. Did you see that thing pass through? So negative 1, negative 3. Looking pretty good. Let's see if it works for the other equation. So we're going to say negative x squared plus 26y squared. So negative x squared plus 26y squared. And then minus 2x plus 104y equals -77. Let's see. Yep, sure enough, there's that intersection point. Okay, so now intersection just means that the point is shared between the two curves. So even though this blue curve doesn't cross this way through the red curve, it still counts as a solution. So we will go to our notes and we will say yes. Okay. And let's try the next one. So the next one, the point we're looking at is -1 comma 7. So let me go into Desmos, clear out those two equations, and put in -1 comma 7. And our first equation is -2x squared plus y squared. So -2x squared plus y squared. And then plus 2x plus 17y. So we'll say plus 2x plus 17y equals, whoops, wrong program, equals 49. All right, whoops, 49. Looks like it's up here some. So let's scroll up a little bit. There it is. And there's our point up there. Uh-oh. So our curve is not going through that point. This is not looking good. Let's see what happens when we put x plus y equals 2 in there. Nope, sure enough, 1 comma 7 is not the intersection point. It's that point right there with the ugly decimals. So we'll go back to our notes and we will say no, not an intersection point. So not an intersection point. Okay. So that's how we test if a point is a solution. What we're going to do on the next page, just a couple of examples, we won't do all of these, but just a couple, is we're going to be asked to solve the system. So we're going to be asked to find the solutions. So I'll go ahead and clear out what we have here in Desmos, and we're going to type in 3x squared plus 2y squared. So 3x squared plus 2y squared minus 54y equals 143. So there we go. We've got ourselves, this is actually, if you zoom out, it's an ellipse. Kind of looks like a circle that's been squished. And then we're going to type in x minus 3y minus 3y minus 3. I think it was equal 0, but let me double check. Equal 0. Yep. So we're looking for where they cross. Desmos is going to give you a gray dot for intersection points. But Desmos also gives you gray dots for x-intercepts and y-intercepts and maximums and minimums. So we have to be careful here because we see 1, 2, 3, 4 gray dots down here. We only want the ones that are intersection points. So that one and that one. So -3, -2, and 9, 2. And so those are our two solutions. So -3, -2, and 9, comma 2. Okay, and that's all you have to do. Type them in, look for the intersection points. So let's try another one. So I'm going to go in and clear out Desmos. And for my first equation, I'm going to type in 2x squared plus 3y squared. So 2x squared plus 3y squared. And then we're going to do 3x minus 12y. Whoops. 3x minus 12y equals 42. There we go. So we've got ourselves another ellipse. Let me zoom in on it a little bit. And then our other equation is x plus 3y equals 0. So x plus 3y equals 0. There we go. I want the intersection points, so I don't want this point here. This point is an x and a y intercept. That's not what I want. I want where the blue circle crosses the green line. So -6, 2, and 3 comma -1. So let's add those into our solutions over here. So -6 comma 2. And I've already forgotten the other one, so let me go back and look. 3 comma -1. Okay. All right. Let's try. Some of these can get really crazy complicated. So let's just try one or two more. So let's try the next one. Let me go in and clear out Desmos. And I'm going to type in x squared plus 2y squared. And then we're going to say minus 11x minus 3y equals -31. So we've got a little tiny ellipse all the way over here. So let's zoom in on that guy, make him a little bit bigger. There we go. And then our other equation is -x plus y. So -x plus y equals -4. Whoops, what happened to our ellipse? There it is. All right. So if I zoom in on this, it looks like they share a point. It may not cross through, but they do share a point. And I have to look real carefully here because sometimes in Desmos, if they share a point like this, Desmos won't give you the point. So see, there's no gray dot, but it certainly looks like it's right there at 5 comma 1. So I'll go back here and I'll put as our answer 5 comma 1. So you can have 2 solutions, you can have 3 solutions, you can have 4 solutions, you can get crazy wiggly functions where there's like 5 or 6 solutions, or you can have 1 solution. And of course you can have, like we saw, there could be no solution. So let's do one more. So this last one, we're typing in 4y squared plus 34x. So 4y squared plus 34x. And we're going to have plus y equals 52. So plus y equals 52. Let me zoom back out. There we go. So we can see part of our parabola there. It's actually a sideways parabola. And then we've got 2x plus y. So 2x plus y. And then we're going to say minus 4 equals 0. And again, we've got this line that doesn't cross through the point, but they share a point. And so a solution to a system just means they share a point. And it just happens that the equations are simple enough this time that Desmos is able to tell us that it's the point 1 comma 2. So I'll go back to our notes and I will put 1 comma 2. Okay. There are a few more examples here in the notes that you can use if you want to practice some more. But that's basically it. You type in your 2 equations or your 3 equations or your 4 equations and look for those gray dots that tell you that the 2 equations share a point.